Okay, here we go. So I'm going to show you a little bit about building a thermocouple junction. It's not complicated, but I thought it would be easier to show you than to show you a bunch of pictures or something. So we're over in the lab that I did my graduate work in at UC Berkeley, and I'll give you a walk around of the lab on video here in a little bit. But let's talk about these thermocouples. So thermocouples are for measuring temperature. They're a junction of two dissimilar metals. And today when I show you this, I'm going to show you the buildup of a type K thermocouple junction. That's comprised of chromel, alumel, and I think those might be trade names from Omega. Omega sends these wires out in a raw form on these spools that look like this. So you're looking at a spool of alumel. The indication there is telling you the diameter, which is 0.005 inches, and it's 100 feet long, and it's got a Teflon coating on the surface. The chromel is that one, and again it's specified on the outside of the thing, and they are color-coded red and yellow. Okay, and these are quite fine. They are not currently joined together, so I'm going to join them together and show you how to do that welding. So the first thing to do, you have to take the material off the end of the wire. You have to take that Teflon coating off the end of the wire, and you can strip it off with just your finger, with your fingernail. It comes off for these small gauge pieces. I'm going to demonstrate this with a larger gauge piece of wire so that you can see what I'm doing a little better, but you can see that we've got two wires there, one red and one yellow, and they're pretty good size. I'm going to say that this is actually an extension grade piece of thermocouple material, but that's okay. It'll work for us. Okay, so this is a welder. This is a thermocouple welder. It does the weld in argon. You flow argon when you do the weld. And I'm just going to even these two ends up and set my welder. Look here on this surface, I have settings for both the amount of current, and it just gives you a minimum, a medium, and a max, and the time that we weld. And I think for this piece of wire, we're going to weld for medium time and a medium power as well. You hold the wire in the end of this little holder here, and you want to get it's something that you get just some experience with, but you want to get those two pieces of wire sticking out about that far, and I don't know what that far is. Maybe that's a millimeter or so. Okay, and they need to be pretty close together or they won't weld, and these two aren't cooperating, so I'll just keep bending them around until they do. That looks a little better, like that. Okay, now I take this thing and I put it into the welder like this, and the first thing I do is I purge out the air. So that's just purging the welding chamber with some argon. And then I'll reach over here and I'll hit this weld button, and it will, you'll see a bunch of blue flame and sparks come out of there, and it stops automatically. So I just hold the button in for until it stops. Okay, that's it. Let's see if it welded. So we open this guy up and we look, and it looks to me like we got a weld there.
Let me see. Okay.
Good. Okay, so why don't we try hooking this thing up? I'll shut this off and put in our little guy there that keeps that clean. And now we're going to walk over here and show you how to hook these things up to a junction. Okay, so what I have here on this table are some of the little end pieces that we use to attach pieces of thermocouple wire together. And I'll work with one of these guys, maybe this one right here, and actually, why don't I just show you with this one that I'm already working with. So here we have our red and yellow wire where it goes into this plug receptacle. And if you look closely, I don't know if the camera will show it, but there is a positive sign here and a negative sign here. And you want to keep these straight because, throughout your assembly, because you'll read negative values for temperature. It'll throw things off for you. So there's just a couple little screws here that you can loosen and tighten to get your wires attached. And if you don't know already, you want to loop your wire in such a way that when you attach it to the screw, it tightens. Okay, so you put that in there, and now when that's on there and you tighten that screw, it's going to sort of pull the wire around it. The way that I remember which is positive and which is negative for type K thermocouples, well, gold is positive. That's gold is one of UC Berkeley's colors, and red, well, that's negative, and that's another school that's right down the road. Their color is negative, so we won't mention which one that is. But you get the idea. Okay, you use your own way to remember, but because I wouldn't want you guys to think anything bad about Stanford. I mean, well, whatever school I was talking about. Okay, so you tighten those down, and that tightens its way on up, and now your thermocouple is attached to a plug. Now, I just sort of did this for expediency. I typically would use a male plug for the end of this thermocouple lead like this, and then you end up with an assembly that looks something like this. So here's an assembly of a type K thermocouple, and this has come from Omega pre-assembled. Okay, so you didn't have to do any welding of leads or anything like that, but it's all put together the same. The actual thermocouple leads here are inside a stainless steel sheath, and this would protect it from the conditions in which you're measuring high temperatures. Okay, once we have this assembly, the next step is to plug it into some kind of data acquisition system. You could just hook this up to a multimeter and get a voltage. There are a couple difficulties with that, which we'll talk about during our lecture, but the simple explanation is that we're going to learn about cold junction compensation. And when you just do a multimeter on this thing, it's not cold junction compensated, so your temperatures aren't going to be exactly accurate. Okay, what we are plugging this into is this assembly here. This is a National Instruments data acquisition board, specifically designed for reading thermocouple measurements. And it plugs into a chassis that can take several different modules. It can read RTDs, or there can be input-output control type modules. And the module itself is connected through extension grade thermocouple lead to a whole bank of 16 thermocouple inputs. And this just allows you to quickly connect and disconnect. And one of these little guys is bigger than the other, and that keeps you with your plus-minus relationship intact, as long as you have your plus and your minus attached to your data acquisition board correctly down here. One other thing I'll show you here, this is a stainless steel sheath, as I said. This is an example of sort of a home-built ceramic sheathed thermocouple assembly. And what this is the very thin wire that I showed you previously. The person who built this would have welded those together and then strung them down this ceramic sheath that has two holes side by side, and this provides shielding to the length of the thermocouple wire while allowing the tip of it to be in contact with the gases that you're interested in measuring. Okay, I think that's it for the thermocouple assemblies, and we can stop there, and I'll jump in a second to some other material, and we'll take it from there.